to the continuation of our discussion. So we shall continue with the actual component method. In the first video, what we learned was how to determine the x and y component of a vector. This time, we're going to evaluate or determine the resultant vector of, say, 2 to 3 or more vectors. In doing the component method, we simply follow the four steps. First is to draw the vectors in the Cartesian plane, compute the x and y components of each vector. Note that also the sign of each component based on the location in the Cartesian plane applies. Third, add all the x and y components. And lastly, calculate the resultant and direction using the formula below. If you look at the formula, it is similar to the Pythagorean theorem that we used in our previous discussion. So for example, we have the three vectors, vectors A, B, C. Vector A, 50 newtons, 30 degrees north of east. Vector B, 25 newtons, 65 degrees west of south. And vector C, 45 newtons, east. So the first step is to draw the vectors in each Cartesian plane. Now, this is not necessary. It's not necessary that each vector must have a Cartesian plane. It's up to you. You can combine all of them in one Cartesian plane. But for the sake of clarity, I will be drawing them in separate Cartesian planes. So for vector A, it says north of east. So north of east is in the first quadrant. So therefore, the vector lies on this quadrant, B. Let's assume this is 30 degrees. This arrow represents vector A that forms 30 degrees with the horizontal, north of east. The value is 50 newtons. Say vector B. Vector B is in 65 degrees west of south. West of south means it is in which quadrant? The third quadrant. So meaning to say the arrow lies here. Say this is 65 degrees. The vector or this blue arrow is our vector B equivalent to 25 newtons and forms an angle with respect to the south direction or to the y-axis. So this is 65 degrees. Now I should note as well that it is beneficial if we also consider the angle that this vector creates with the horizontal. Okay, the drawing is not to scale, but let's say this is 25 degrees. So this is an angle with respect to the x-axis or the west direction instead of the south direction. Now I'm noting this because later in the computation, I will be using an angle that is measured relative to the x-axis instead of the y-axis. Next, the third vector, vector C, 45 degrees east. So that's along the horizontal, not visible. But this arrow to the right is our vector C, which is 45 newtons. Now, it is important that you visualize the vectors in the Cartesian plane so that you can determine the signs as well of each component. So, for example, vector A lies on the first quadrant. We know that the quantities or coordinates in the first quadrant would always have a positive, positive sign. As for the third quadrant, we have a negative, negative sign. And for the horizontal axis on the right or the east, that's the positive x-axis. All right. So now that we have drawn and visualized the vectors, it is now easier for us to write the components in tabular form. So earlier, the first vector, 50 newtons, was in the first quadrant, creating a 30 degrees angle with respect to the horizontal. So Um, Following the method we did in the first video, the horizontal component is on the adjacent side of the angle and the y component is on the opposite. That means we can use cosine again for our x component and sine for the y component. And then we copy the value 50 newtons, 50 newtons here. Okay, so the angle is, replace that with 30 degrees. This one as well, 30 degrees. So if we'll do the math, the answer for the x component would be 43.30 newtons. Kindly follow using your own calculator. And this one, the y component, 25 newtons. Now again, north of east is in the first quadrant. That tells us the x and y components are both positive values. Next, for the vector v, it is in the southwest. And earlier, upon measuring the 65 degrees angle, I also measured the 25 degrees angle, the complementary angle of this given vector. So um, I highly suggest that we use angles that are measured from the horizontal rather than the vertical. If we use 65 degrees as our angle, we will interchange sine and cosine. But for the sake of uniformity, I will use 25 degrees so as to not confuse the tabular form. Okay, remember I'm using 25 degrees as the angle here so that my angle is measured from the horizontal and I could use cosine theta still in my tabular form. So if I use the 25 degrees angle, the opposite side would be the vertical component and the adjacent side would still be the x component. So everything remains as is. So cosine 65 here for the x component and sine, oh rather 25 and sine 25 degrees for the y component. And then simply copy the given magnitude. So 25 newtons and then 25 newtons here. To calculate this in your calculator, you'll get, for the x component, 22.66 newtons. And for the y, you get 10.56 newtons. Now lastly, don't forget this step. The south of west is in the third quadrant, remember. So in the third quadrant, the signs of x and y are both negative. So we attach a negative sign in front of the values. All right, moving on. Vector c. So for vector c, it is along the horizontal or the east direction. So since there is no y component, then we can say that the y component is 0. All right, so just put a 0 there if you want, or p vector is equal to 0. Or a more formal way, you can still compute 45 cosine, or rather sine the angle along the horizontal. But since this is the east, that's 0 degrees, obviously. So sine 0. If you type it in your calculator, 45 sine 0 is still 0. Okay, so you can skip the calculation if you want, or you can place the calculation. Still, it's up to you. And then for the horizontal component, since it's exactly along the x-axis or to the east direction, whatever is the value given for the vector, that is also our um, x component, 45 newtons. And since it is on the east, that's a positive value. Okay, again, a formal way of computing for this would be 45 newtons cosine 0. If you type this in your calculator, you'd get the same value, 45. Okay, again, you can skip this part or you can write this down. Okay, so now what we're gonna do is to get the sum of all the x components and the y component. So you get the sum of the x components of A, B, and C. When you um, get the, or when you type everything in your calculator, including the signs, you should get a positive answer that is 52.46. Take note that this value is already rounded off to the second decimal place. And then for the y component, adding everything up, we get a positive 14.44 newtons. Newtons. All right. Now, this is the second step. Oh no, the third step. The last step is to determine the final value. All right, so the last step is to solve for the resultant vector. But before that, we will first visualize the vectors in graphical method. So the first vector is in the north of east, followed by a west of north, and then another vector to the east. So this is our vector A, vector B, and vector C. Now, where is the resultant vector then? If you follow the tip-to-tail method or the polygon method, we draw a vector from the tail of the first to the head of the last. And from this drawing, you can see that our resultant vector is actually in the first quadrant. And in the first quadrant, the x and y coordinates are both positive. And this is a proof, will serve as your proof that the resultant vector is really in the first quadrant because our values earlier are both positive. Now, before I continue, I'd like to correct our sum of x component value. It is not 52 point something, 0.46. It's actually 65.64 newtons. And our summation of y remains 14.44 newtons. And they are both positive, which agrees to the coordinates in the first quadrant. And in the first quadrant, the possible directions you can only have are either north of east or east of north. Okay, so in this case, we already have an idea that our final answer or final vector is actually in the first quadrant. So we're going to do the component method. Okay, so the component method applies here because our main vector, I'm going to draw it like this. Our main vector, the yellow arrow, actually has the sum of x components like this and the sum of the y components like this. Okay. And if you notice, this is still a right triangle. So the Pythagorean method still applies. It's just that you have added all the x components and all the y components that will serve as the parts of our triangle. Okay, so following this method, the resultant vector is the square of the x, which is 65.64 newtons, squared plus the square of 14.44 newtons. And then if you extract the answer or square root, the answer should be, hang on, should be 67.21 newtons. Okay, now this is only the magnitude of the vector. Now, the last step is to determine its direction because a vector has both magnitude and the direction. Now, normally we use tangent theta, which is equal to the summation of the y and summation of x components. Now, why y and x? Because in tangent theta, you use the opposite over adjacent. And it so happens that the x and y components are also on the adjacent and opposite side. So looking back in my direction or figure here, the y component is along the opposite of the angle that we're looking for, and the adjacent f sub x right here. Adjacent then opposite of the angle. So we will use the summation of all the y and summation of all the x and tangent theta to get the final angle. So to get the final angle, you use arctan. Tangent theta is equal to tangent negative 1 of the ratio, our summation of y, 14.44 newtons all over 65.64 newtons. And that will be equal to, if you type it in your calculation, press shift tan, and then the ratio, 14.44 divided by 65.64. And then the answer is 12.41 degrees. This is now the direction of our resultant vector. Now finally, you can write your final answer as, or in vector form. Our resultant vector is 67.21 newtons, comma, 12.41 degrees. Since the x and y components or sum of x and y components are both positive, it means in the first quadrant, and the direction is north of east. And this is our final answer. To end this video, here is a sample question or a checkpoint question that I'd like you to answer during your all or we periods or your breaks. A plane leaves the airport on the bearing of 45 degrees, traveling at 400 meters per, per hour. The wind is blowing at a bearing of 135 degrees at a speed of 40 meters per hour. What is the actual velocity of the plane? So if we evaluate this question, you're given two vectors which are both speeds, or rather velocity. So we have velocity A and velocity V. In this table, kindly remove this row and have the first two rows for your vectors A and vectors B. Kindly fill this column up with the given on the problem and then solve for the x and y components. Get the sum of all x and sum of all y components. And lastly, follow the Pythagorean theorem and the arctan or tangent theta formula to determine the direction. Once you're done, take a picture of your work and send the picture in the assignment bin that I will post in our MSD. That is all. Thank you.